Okay, in exercise 155, we are asked to use our graphing calculator. Use a graphing utility to find the derivative of the function at the given point. Then find an equation of the tangent line to the graph of the function at the given point, and use your TI Nspire to graph the function and its tangent line in the same viewing window. So the function is given right here. It's a rather big function. We could, of course, find the derivative, but here we do it with the calculator. So let's see how that works. What I do is I go to menu. So first of all, I already typed it in, but you have function 1. Then you go to menu, analyze graph, derivative, dy dx, and you want to find the derivative at the point 0.5. So here it is. I type 0.5, enter, and I get the slope of -3. Okay, so from here we need to work a little bit. We know now that the slope is -3. We have a point, so we can find point slope form. The graph of the tangent line is y minus 3/2 equals -3 times x minus 1/2. This is perfect. We could stop here, except that we have to graph it in our TI Nspire, so we can't plug such an expression in. We need to solve for y equals -3x minus 1/2 plus 3/2. You can plug this in, or you can expand y equals -3x plus 3/2 plus 3/2, so y equals -3x plus 3. So one or the other, both of the y equal, well, any of these three is fine. So when I do that, I go to tab, I select the second function. I already typed it in. I only need to add it, and we can see that yes, it really looks like the tangent, the red line is a tangent line to the blue graph. Second exercise, 181. So for this question, show that the derivative of an odd function is even. B, show that the derivative of an even function is odd. They help us, they tell us exactly what it means. An odd function means f of -x equals -f of x. And if its derivative is even, then it means that f prime of -x equals f prime of x. So let's start with that. F of -x equals -f of x. That's the definition of an odd function. Just to remind you, an odd function is maybe something like this, right? So it's symmetrical about the origin, or you can say that you can make a rotation of 180 degrees, or you can also say that if you take one part, you can flip it over the x-axis, and then you can flip it over the y-axis, and you're going to get the second half. So different ways of interpreting odd functions. But the fact is, if I pick an x here, then this is f of x. So notice how negative f of x is a negative number like this, if I may. And if I go now to minus x, then f of -x is this. So I get minus f of x is equal to f of -x. Okay, so if I take the derivative of f of -x, it's in fact a chain rule. The derivative of f is f prime, and then I have to multiply by the inside derivative, which is -1. On the other side of the equality, the derivative of f of x is f prime of x. If you want, you can multiply by the inside derivative, but the inside derivative is just 1. So if I compare these two, this is a negative, right? So it's just negative f prime of x equals negative f prime of, I forgot a negative here, negative f prime of negative x equals negative f prime of x. If I multiply by negative 1, I get f prime of negative x equals f prime of x. So this is the perfect segue for b. What does it mean when a function is even? A function is even when it is symmetrical about the y-axis, maybe something like this. So if I pick a certain x, f of x is here. On the other side, at the value negative x, f of negative x is here. So these two are equal. So that's what we obtain in question A for our derivative. The derivative at negative x is the same as the derivative at x. Let's have a look at this graph and try to interpret it a little bit. If you look at the derivative at this point here, you can see that it's negative. And if you now go to the point right there at negative x, it's the same slope. So the result of an odd function f is that the slope is symmetrical. F prime is odd. At this value here, let's call it a, f prime of a is 0, f prime of negative a is also 0. So this property has a mirror property, if you may, that if we have an even function, f of negative x equals f of x, then its derivative is odd. And that's pretty quick. F prime of negative x times negative 1, I just took the derivative, multiplied by the inside derivative, equals f prime of x. So I took the derivative on this side. And if I rearrange this, it's just negative f prime of negative x equals f prime of x. Or, if you prefer, you can multiply by negative 1. We get f prime of negative x equals negative f prime of x. So this time, the derivative is odd. Let's have a quick look at a random point here, a. Here's the slope at a. If I pick the point at x equals negative a, you can see that it's the opposite. Alright, so that's it for these two exercises.